Hello, my name is Finton Sinclair. I'm studying Sustainable Systems Engineering, and the innovation I chose to critique was heat insulation solar glass. So you first might ask, what is heat insulation solar glass? Well, HISG, as it's otherwise known as, is a form of photovoltaic glass, which is a technology that allows for the conversion of light into electricity. This process is enabled via the use of semiconductor-based photovoltaic cells, much like those that are found in modern solar panels. HISG in particular is a more complex form of solar glass that allows for much greater yields in energy production through taking advantage of high reflectivity heat insulating film, allowing for an overall higher level of photon absorption and thus energy production. The primary discipline involved in manufacturing HISG is material engineering within the construction industry, focusing on low or zero carbon emission buildings through thermal insulation and sustainable energy production. Elements of innovation. So why was HISG invented? Scientists and engineers concerned about the energy use involved in maintaining a building's heat thought of how to capitalize on the large use of glass in modern-day homes, large commercial buildings, etc. Through the development of PV glass, this made the previously single aesthetic standard use glass able to be replaced with glass that could both serve an aesthetic function while also being able to produce energy at the same time. HISG is an innovation which allows for the further exploitation of this opportunity by maximizing the insulating effects of glass while increasing the efficiency of energy generation through use of PV cells. HISG strengths. In 2016, a series of tests were conducted on two separate houses, both built of the different types of glass, being ordinary glass and HISG glass. Figure 2 shows how HISG greatly outperforms ordinary glass on the metric of insulation, as the ambient air temperature of the HISG house barely rose at all when compared to the ordinary glass due to its great level of insulation. Another test that was conducted on the same test houses was seeing how much energy was needed to maintain the houses at a standard comfortable ambient temperature. Figure 3 shows that a much higher level of energy through use of cooling was needed to maintain the comfortable ambient air temperature than what the HISG house needed. In addition to this, the HISG actually produced a net output in energy from its through use of its photovoltaic cells. Limitations of HISG. HISG blocks high amounts of visible light coming into the inside face of the glass. Thus, using them could negatively influence the functionality of their use as windows. The widespread implementation of HISG has yet to be introduced as well, so it may need more research and development for them to become more commercially available. It can be quite expensive when compared to ordinary glass, as just PV glass alone can cost 6 to 15 AUD per square meter. HISG is thicker than normal glass as well. As a result, this could lead to increased construction costs for installation and can impact the overall aesthetics of the building in which it is situated. Recommendations of improvement. So how do we capitalize on the strengths of HISG? Well, installing them on large commercial buildings such as skyscrapers could lead to the building itself being completely energy self-sufficient and perhaps even a source of energy for the main power grid. They could also replace solar panels in normal residential houses or perhaps use both at the same time for a higher level of energy production. And their high level of insulation could lead them to be the best choice of glass in areas that need minimal heat transference both inside and out. So they could be ideal in situations such as Antarctic laboratory facilities. So how do we mitigate the weaknesses of HISG? As HISG allows for limited light to go through, it could be used in low light areas. By slimming down the standard HISG thickness, this could lead to their widespread implementation as they'd be more readily available for large-scale use. And installing a more transparent version of the insulator that could replace the current semi-opaque insulators used in current HISG today could make them more available to use in places where highlight levels are needed, such as commercial shopping centres or other such buildings.